Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC B1226, refers to a short in the in-car temperature sensor circuit within the Honda Accord models from 2008 to 2012. This specific error indicates that the circuitry monitoring the in-car temperature sensor is not functioning properly, potentially leading to inaccurate climate control settings or failure to regulate cabin temperature. The primary components involved in this circuit include the in-car temperature sensor, located usually near the front of the cabin, and the climate control unit, which interprets the sensor data to manage the air conditioning and heating system. If this circuit is interrupted or shorted, it can result in various complications with the vehicle's climate control system, causing discomfort to passengers. Identifying and fixing the source of this short is essential for restoring proper climate control functionality in the vehicle. The in-car temperature sensor is a critical component designed to measure the ambient temperature within the cabin. It sends this temperature data to the climate control unit, which manages the heating, ventilation, and air conditioning system based on the readings received. The sensor is usually located near the center of the dashboard or inside the glove compartment and requires accurate operation to ensure that the vehicle can adjust the climate settings correctly. When the DTC B1226 is triggered, it suggests that a short circuit may be present within this sensor's wiring, leading to erroneous or non-existent readings. This malfunction can prevent the climate control unit from adjusting the heating or cooling appropriately, affecting passenger comfort and safety. Therefore, understanding the location and function of these components is crucial for effective troubleshooting. There are several potential causes for the DTC B1226 being triggered in a Honda Accord from 2008 to 2012. One primary cause is a short in the in-car temperature sensor circuit, which can occur due to wiring insulation breakdown, providing unintended paths for electrical current. Loose connections in the wiring harness that connects the in-car temperature sensor to the climate control unit can also lead to intermittent failure, impacting the reliability of the temperature readings. Damage to the wires or connectors can disrupt the circuit and prevent electrical signals from transferring accurately. Furthermore, environmental factors such as moisture ingress can corrode connectors and wiring, leading to electrical shorts or open circuits. These underlying issues need to be carefully examined to restore functionality and ensure proper cabin temperature management. The symptoms associated with DTC B1226 are primarily related to malfunctioning climate control features. Drivers and passengers may notice inconsistent cabin temperatures as the system struggles to react to incorrect sensor readings. This inconsistency can cause discomfort and frustration during drives, particularly during extreme weather conditions. Additionally, the vehicle's dashboard warning lights may illuminate to alert the driver of the detected fault, which can include indicators for the climate control system. Some users might report dummy gauge readings, where the climate settings do not correspond accurately to the actual temperature within the cabin. Recognizing these symptoms is crucial for timely diagnosis and repair, ensuring that the vehicle's climate control system operates effectively. The first step in troubleshooting DTC B1226 involves using the Honda Diagnostic System HDS to clear the existing diagnostic trouble code. This will help in determining if the issue is persistent or if it could be a transient error. Following this, turn the ignition switch to the lock position and then back to the on position, ensuring that all electronic systems in the vehicle are reset. The next crucial action is to run the self-diagnostic function using the HDS or directly through the climate control unit. This self-diagnostic process will allow the system to reevaluate the health of its components and identify whether the DTC B1226 or associated codes reappear. Monitoring the results at this stage can help differentiate between a persistent failure and a temporary glitch caused by external factors. In this second troubleshooting step, the technician should check for any diagnostic trouble codes that may have reappeared after performing the self-diagnostic function. If DTC B1226 is indicated, this confirms that the issue is still present in the system, prompting further investigation. If DTC B1226 does not show up, it suggests that the failure could be intermittent. In such cases, it's essential to assess the in-car temperature sensor circuit for loose wires or poor connections. This might require visual inspections of the connectors and wiring along the length of the circuit to ensure that there are no loose ends, fraying, or other visible damage. Establishing the presence of DTC B1226 will guide the technician on whether to proceed with further testing or focus on potential intermittent faults. Next, the technician should turn the ignition switch to the lock position to safely work on the vehicle's components. After ensuring that the vehicle is powered down, the in-car temperature sensor can be removed for testing. This component is vital for reading the ambient temperature inside the vehicle, and its proper function is paramount for effective climate control. Testing the sensor will typically involve checking its resistance or voltage according to specifications laid out in the repair manual. If the sensor is found to be malfunctioning or outside of acceptable ranges, it may indicate the need for replacement. Conversely, if the sensor tests normal, it directs the diagnosis to the subsequent components in the circuit. After verifying the status of the in-car temperature sensor, the next logical step is to disconnect the climate control unit connectors, specifically connector A, 28P, and connector B, 12P. It is important to examine whether there is continuity between terminal number 26 on connector A and body ground. This step helps determine if there is an electrical short causing the DTC B1226 to persist. If continuity is confirmed, it indicates there is indeed a short to body ground that needs to be isolated and repaired within the wiring between the climate control unit and the temperature sensor. Properly addressing this wiring fault is crucial to ensure that the electrical signals can flow as intended and that the climate control system functions correctly. In this step, the technician should assess whether there is continuity between terminal number 26 of connector A and terminal number 10 of connector B on the climate control unit. This continuity test is essential to indicate whether the wiring between the climate control unit and the in-car temperature sensor is intact. If continuity exists, it points to a potential short in the wire, which necessitates repairs to rectify the underlying fault. Should there not be continuity, the technician is advised to substitute a known good climate control unit to verify whether the initial unit is malfunctioning. This step is key in isolating the fault to either the wiring or the climate control unit itself, ultimately allowing for targeted repairs. After completing all necessary repairs based on the previous troubleshooting steps, the technician should carefully reinstall all components to their original positions. Following the reinstallation, it's crucial to clear any DTCs using the HDS to reset the system. Once the codes are cleared, the climate control functionality should be tested thoroughly. This involves running the climate control system through its various settings to ensure that it is reading temperatures accurately and responding as expected. Monitoring the functionality during testing will confirm whether the repairs have resolved the underlying issue associated with DTC B1226. Confirming the successful operation of the climate control system is vital for user comfort and satisfaction in the vehicle. Preventive maintenance is essential not only for ensuring the reliability of the climate control system, but also for overall vehicle performance. Regular inspections of the wiring associated with the in-car temperature sensor can help identify wear or damage before it escalates into a fault. It is equally important to routinely check the performance of the in-car temperature sensor to ensure it is providing accurate readings, allowing sufficient time to replace it if issues arise. Maintenance of connectors, including cleaning and ensuring secure fittings, helps to mitigate issues due to loose connections or corrosion. By implementing these practices, vehicle owners can significantly reduce the likelihood of DTC B1226 reappearing and ensure consistently comfortable driving conditions. In conclusion, effectively diagnosing and troubleshooting DTC B1226 involves identifying symptoms accurately and following the detailed step-by-step guide. Understanding the components involved, the in-car temperature sensor and climate control unit plays a pivotal role in the troubleshooting process. Regular preventive maintenance can diminish the chances of similar errors occurring in the future. Using tools like the HDS for diagnostics ensures that the technician can clear DTCs accurately and verify the system's functionality after repairs. Ultimately, addressing such issues promptly not only restores the vehicle's climate control system, but also enhances overall driving comfort and safety. Please like and subscribe to the channel. See you next time.